Data analyst, data engineer, and data scientist arguably spend majority of their time cleaning data. I definitely agree that this is not the sexiest part of these type of roles, but data cleaning still remains one of the most important skills that you can have in the job market. And so my goal in this video is very simple. I want to show you end to end what a data cleaning process with Python looks like. And there are a few reasons why I think this video is going to be super useful to you. First of all, we're going to use tools that are actually used in a real work scenario, and so not really tools that you can find online but are not actually used in the real world. Second, we're going to work with Python, which is a tool that is super important for data scientists, data engineers, and data analysts. And throughout the tutorial, I'm going to also show you some Python concepts that might be useful in case you want to revisit some theoretical aspects of this coding language. Third reason, I'm going to show you a bit of a raw format of data cleaning, which means that this is not going to be a very clean tutorial where everything goes well. I'm probably going to get some errors and trying to debug those errors, so that you can also see how I reason as a data analytics professional when I encounter errors and trying to find the best solution. And also this is going to be very useful for complete beginners with Python, but also advanced people, because we're going to start from an easy level, but towards the end of this tutorial you will see way more advanced concepts that I usually use in the real work scenario again. And also we are going to work with the business data, which are very similar to what you can encounter in a real workplace scenario. And so not random data about sport or music, but actually things that are used in departments in a real company. If we never met before, I'm Lorenzo. I'm a data analytics lead with over 7 years of experience working at companies like AWS and Deloitte. And I'm also the founder of the Analytics and Automation Academy, which is a 6-week program where I teach you everything you need to know in data analytics, and I will follow you on a one-on-one basis until you land a job offer in this field. This is not really a video course where I only teach theoretical aspects. This is pretty much the only resource that you need today to actually land a job offer in the world of data analytics. And so if you're interested in learning Excel, SQL, Tableau, Python, work together with me on 4 advanced projects, build a portfolio website, and also AI agents end-to-end, plus learn the domain knowledge that you need in the actual field, and then optimizing your resume, LinkedIn, having me preparing you for coding interviews and business case type of scenarios, then definitely make sure to check the link in the video description. Applications are open right now, so definitely apply, schedule a call with me, and I'm gonna see if you are a right fit. And now without further ado, let's start our end-to-end data cleaning project using Python. So the setup of this project is pretty simple. I am, as always, in Google Colab is my favorite editor for coding in Python. Super easy to set up. You just open Google Colab on your browser. It's all free. You don't have to install anything, and you can just start coding straight away. And the thing that you see here is I'm basically importing pandas as PD, import numpy as MP. These are the only 2 packages that we're going to use in this tutorial. Also, I'm creating a data frame, and this is going to be based on a CSV file that you will see in video description. So make sure that you load it on your laptop as well. And what I'm going to do is simply doing a pd.read CSV file. The CSV file name is called marketing campaign data messy.csv. This is going to be marketing data, and we're going to see this in just a second. What I'm doing is simply printing some initial information about our data set. So I want to see the shape for the rows as also the shape for the columns. So let me run this code here, and result here that is printing on the screen is simply having 2020 rows and 12 columns. Our data frame is called df, so I can also show a bit of information about this data frame here in the screen so that we are all clear on which kind of information we are working on. So you can see that we have information about different campaign IDs. We have the name of the campaign, so these are all marketing campaign that this business is running. We have the start date and the end date of the campaign. We have the channel, so this campaign can be run on TikTok, Facebook, email, and so on. We have the number of impressions. We have the number of clicks. We have the amount spent based on these campaigns. We have the conversion. We know if the campaign is now active or not. We also have the clicks and the campaign tag. So these are a lot of information about campaigns. This is definitely replicating what is happening in a real business scenario, because these are information that are pretty common to find for marketing campaigns. And so we are just wanted to make sure that we are working with a data set that is representing exactly what's happening in a real business. And now our goal is is to make sure that this data set here that you see in the screen is clean, is ready for analysis, because it is definitely not in a right state right now. Maybe you don't see some missing stuff. I would challenge you now to, pause this video and just check if you see some anomalies in the screen. But for example, I see dates here. Sometimes there is a timestamp, sometimes there is not. I also see in the spend, sometimes there is the dollar amount, sometimes there is no dollar amount, and a lot more stuff that maybe you're not seeing at first sight, but we're gonna analyze it together and just making sure that we clean this data so that it is ready for analysis. So again, data cleaning is such an important task for any data analytics task. Is initial step that we have to make sure in order to progress on the more fun thing to do in data analytics, which is actually finding insights on this data set. So if you're ready, if this setup is clear, as always, make sure to check the video description to download all the resources that we're going to use in this video. But if this is clear, let's get started with this project. So the way that I'm going to proceed on this project, I simply added here a few sections and the titles of our steps that we're going to take for this data cleaning process. So first step, for example, is cleaning headers, and I'm going to go ahead and writing some Python code that we're going to use to clean this data set. And so again, make sure that potentially you have it in your screen so that you can follow along. And so let's start with the first thing that we want to clean on our data set, which is based on the headers. So the first thing that I want to show you before we actually clean the data, I want to definitely show you what is the problem that we're trying to fix. So what I'm going to do here is printing and then opening bracket and do a df.columns. I'm going to move the columns into a list and then open close brackets. So let me run this part here. And this one is simply printing the list of columns that we have. What I see here in our column list is that in some cases we have some spaces at the start of the column name and even at the end of the column name, like this campaign ID. And these are definitely things that we want to clean up because that can cause some issues later on in our project. And so what I want to do is doing a df.columns so that I select all columns that we have in our data set. And then I'm going to do a df.columns again. All columns would be strings. And then what I'm going to do is doing a strip, which is simply removing all the spaces at the start and end of the string that we have. Also, I'm going to do a str, so string dot lower, because I want to convert all the column names into lowercase. And then also I'm going to do a string dot replace. And just in case we have a extra space, I'm going to actually follow the suggestion of Google Colab. And let me remove this part here. But what I want to do here is simply replacing an empty space with a underscore. So this is basically three operations. So the strip, the lower, and the replace, three operations that I do in only one line of code to make sure that our columns are properly formatted. I'm going to print a message maybe saying fix applied, something like this. And again, I'm going to follow the suggestion of Google Colab. I'm going to print the new df.columns to list and basically seeing what's the new columns that we have. So let me rerun this part here. And now, as you can see here, I have the first one is the list of columns, the initial one that we had. So I'm reprinting it again. And then just as a separation, I said here, okay, fix applied. And this now is our new cleaned column names. So as you can see here, campaign ID, we removed that extra spaces at the start and end of the column name. Also, we brought everything lowercase, so that is more clean. And now we have basically all of our columns that are ready and in a clean status. Now, on our next step, I want to check the column spend because I showed you already we have some issues there. So again, let me try to show you what the problem is in this column. So I'm going to define a column called dirty and then spend underscore mask. This one is equal to df and then spend. I'm going to convert this as type and then string. And then I'm going to follow Google Colab suggestion. I want to select where this column contains this dollar sign in here. Now I can also print where we find this problem. So I'm going to do print and then open brackets df.lock, and then here I'm gonna put our variable, so dirty. Let me actually paste it from here. I'm gonna do a comma, and then in here I want to just select the campaign ID and then the column spend. and then simply want to show the first 3 rows of this. So let me try to run this part here. And in here, as you can see, I have 3 campaigns ID that I want to show, where the spend, we have this kind of dollar sign here that is causing a problem because, we have a number with a string at the start. So again, we want to make sure that we have a number here because maybe we want to calculate the sum and like do some mathematical operations. So we don't want to have the dollar sign at the start. And so what I can do here to fix this is, again, I'm going to follow what Google Colab is telling me to do. So I'm going to define again a new version of the spend column. This spend column, I'm going to convert it into a string simply because I want to operate with a string. And so what I'm saying here is that I want to replace any characters that is not a digit, a dot, or a minus with basically nothing. So this is just to make sure that we have only kind of numbers in our string. So that is exactly what this line is doing. And then now, because I convert it into a string, I want to convert it back to a numeric variable. So what I'm going to do is I'm going to copy paste this part here, and now I'm going to do a pd dot to numeric, and then again I'm going to select df spend, and now actually I'm going to grab the same print statement that we had before just to see how these 3 campaign IDs are fixed after the data cleaning process that we just implemented. So let me rerun this part here, and as you can see here we have our mask, let's say the initial step that we had before, and then now with the fix apply we have the right format for the numbers. So you see that there is no more dollar sign as we expected. Now you might have noticed, and actually I'm going to implement this strategy a lot in later on in this tutorial, that I'm creating a variable all the time called dirty spend mask. And the reason why I'm creating this variable is that I want to identify what we are trying to clean, but I also want to refer it back to it, to the initial stage, even after our data cleaning process. And so that is why I'm creating this mask variable, just because I want to see the before and after, if that makes sense. So that is actually a very good common practice when you do data cleaning, so that you can go ahead with your data cleaning process, but also to save a previous version on how the data looked like originally. Now let's get on with the next step of our data cleaning process. So this is categorical typos. So we're gonna do a fuzzy logic here. So first of all, what is the problem here? So I'm going to do a print and then open brackets df, and then in this case I'm interested in the channel column, and I want to print the unique values from this column. So let's do this part here, and as you can see here in the channel we have, for example, TikTok written in this way, but also tick_talk, and then also Facebook different ways. So we basically have a column that is channel, but then inside it we have many different values that should actually be merged together. So again, that's something that happens quite a lot of time, different values that actually refer to the same thing, and so obviously we want to clean this column here. And so how do we do this? Well, we can create a cleanup map. So let me show you how that looks like. So I'm gonna do equal and then curly brackets, and so a bit of a manual process here, but I'm simply bringing back the right format here. So first thing is this Facebook, so let me copy from here. So this one, Facebook with a semicolon, should be this, which is the right format. Okay, and then comma. This Instagram, let me find it. This Instagram here is also wrong, clearly. So this one will become this one here, which is the right version, and then comma. This one is definitely wrong as well. So let me put it in the right format. So Google Colab is helping me here. So perfect. Google becomes Google Ads, tick_talk become TikTok, and then email. Yeah, we're gonna keep this right format here. Also, I am going to deal with the NA. So again, I'm gonna follow Google Colab suggestion. So I'm gonna change this NA into a null value based on NumPy library. And so I'm happy with this one. And so now what I need to do is redefine df channel. So again, I'm gonna follow Google Colab, and I'm gonna replace the values in df channel with our cleanup map. And then I'm going to print our kind of fix applied that we print all the time when we complete our cleaning step. And then now I'm gonna reprint again the unique click value for channel and see if we clean up the mess that we had before. So let me run this part here. And now, as you can see here, again, I'm reprinting the original status, what we had before, and then our fix applied, and then our values that now are looking like way better than before. Now, what we can do is also handling the mixed booleans. So booleans is values like true and false, yes or no, so these kind of values. So that's also a step that we can do together. Again, I'm going to follow Google Colab. I'm going to print what we have in the active column. So you can see here that we have different values that actually should be, again, Boolean as I mentioned. So we have yes, but then 0, then no, true, yes, so a bit of a mix of things. And pretty much we're going to follow the logic that we had before. So we need to do a bool underscore map. So I'm creating my map for the right booleans and then opening the brackets. And here, for example, the yes will need to become true, and then comma, the y and also the 1 becomes true. Then we have no 0 and also another 0 for false. So that's perfect. And I think that should clean up all of our messy values for the active column. So now I'm going to again redefine our df and then open brackets, the column is active, and this one will be equal to, okay, again, following what we have for Google Colab, I'm gonna use our bool map to map the right values to what we want in the final stage of this column. Also, in case we have NA values, we are gonna put false. Then we're gonna print our usual message fix applied, and then also we are going to print our active column again and check in the unique values. Gonna run this part here, and as you can see here, again, we have our first initial value for our column, fix applied, and then now we are gonna only see true or false. Now let's get into the dates column, because probably there will be some issues there as well. So I want to print the data type for the start date column. So let's follow what Google Colab is telling us. And so what you can see here is that our start date is not a date as a data type, but it's actually an object. So we want to make sure that the start date is an actual date, so that again, when we work with this date, all of our operations will not fail and cause errors. And so what we want to do here is simply changing the type for the start date. I'm going to again follow Google Colab as a suggestion. What we are going to do is using pandas to convert the start date into date time. And if there are some errors, if for some reasons there are things that we cannot convert into a date time, then we use this coerce that will turn that unparsable format into not a time value. And because we also have the end date in our file, in our dataset, then we're going to do the same also for the end date. So let me put this value here again, following Google Colab suggestion, and then we're gonna print our fix applied. Actually, let me take it from here, and then I'm going to print again the data type for our column start date. So let me go into this one, and then if I run it again, we have the object, which is our initial format, then fix applied, and then now we have the new data type for our column start date that is a date time as we wanted. Now the other stuff that I want to check is actually integrity between the clicks and the impressions. So it is not possible that clicks are higher than impressions. It's logical. Impression is when something appears on the screen of a person, and then the click is actually when that person clicks into something clickable on the campaign. It's not possible that there are more clicks than impression, if that makes sense, because it means that there are more clicks compared to how many times something appeared in a screen of a person. So what we want to try to see here is I'm going to again define an impossible, I'm going to call it impossible mask, and this one will be equal to our df clicks higher than df impressions. Let me remove this part here, and then now I'm going to again follow Google Colab. I'm going to print and I'm going to locate the impossible mask, and for this impossible mask I just want to see the campaign ID, impression, clicks, and only 3 rows for now. So let me run this part here, and okay, so we got an error, and I think that I know why we have this error. So let me print again our data frame. The error that I think we have is something that I noticed before when loading our data frame. We have actually 2 columns that are called clicks. So I think this is causing a problem in this part of the code. And so what I'm going to do is actually pasting this part of the code here, which is basically saying locate the columns that are duplicated and remove the duplicates. So I'm going to run this part here. Then I want to check again if our data frame now looks okay. And as you can see here, we have one clicks column and that is it. The other one disappeared. So this is perfect and running as expected. And so now let me try again this part of the code here. And now this is not causing any error. And also it's telling me empty data frame. So it seems that there is no instances where clicks are higher than impressions. So that is actually kind of a data quality check that we have in place, and everything is clean in these regards. So this is perfect. We can move on to the next step, which is logical integrity for time travel. So what I mean by this is that because we have start date and end date, I want to make sure that we have kind of chronological order between start and end date, and no instances where the end date is actually in the past compared to the start date. So I'm gonna follow Google Colab suggestion here. So I define time travel mask as end date less than the start date, and then I want to locate the time travel mask, and I want to check campaign ID, start date, end date, and only the first three appearances. So let me go here, and what I can see here is that this campaign, for example, has a start date on the 6th of May, and actually the end date is in the past, so the 1st of May. So this is definitely a problem. So now how do we fix this? Well, there is not really like a right or wrong answer. I'm gonna make an assumption here, and I'm gonna assume that the end date is 30 days from the start date. So I'm going to change the end date for these appearances, maybe because I know that campaigns usually are lasting for 30 days. So that is an assumption that I'm making based on maybe my knowledge of this data set. And so that's what I'm going to input for this data cleaning step. And so again, I'm going to do a df.lock. I'm going to select our time travel mask and specifically the end date, because that's what I want to change. And then I'm going to do another df.lock, and following the Google Colab suggestion here and having the start date. And then from the start date, I'm going to do a plus pd.time delta, and I'm going to add 30 days. Now I'm going to print our usual message. Let me get it from above. So I'm going to print our fix applied, and then I'm also going to print df, basically, the same message that I had before. I want to again check the instances where we might still have the error. So let me run this part here, and as you can see here, we have the campaigns fix applied, and then now the same campaign is starting on the 6th of May, but actually ending on the 5th of June. So again, I'm adding 30 days from the start date. So this is kind of just a demonstration that the code is working as expected. Now the next one is going to be a bit more, let's say, advanced, but also I think it is very interesting as a use case. So I'm going to handle outliers that we find in our initial data set. So the thing that I want to actually show is when in the column spend we have massive outliers. So there are different ways to do this, but one way to do this is actually by checking the interquartile range, which actually find the middle spread of our data. So in order to do this, what I'm going to do is creating the first variable called Q1, and basically Google Colab is already suggesting what I want to do. I'm going to use the column spend, and I'm going to find the 25th quantile, and then I'm going to define Q3, which is the 75th quantile. So then I'm going to define the interquartile range, which is IQR, and this one will be equal to Q3 minus Q1. Perfect. And then now what I can do is actually defining upper limit. So I'm going to do upper limit here, and I want to define what is the, let's say, maximum value that I can accept in the column spend. Again, this is more like an assumption or something that I decide in terms of like this data cleaning step. And the way that I'm going to define the upper limit is basically starting from Q3 and then summing 3 times the interquartile range. And then again, as suggested by Google Colab, I'm going to define this outlier mask, and I want to check the instances where the spend is higher than the upper limit. By the way, I'm going to tell you why this is the logic that I'm using. But I'm just going to check the campaign IDs where we have the spend that is an outlier. So let me again follow the suggestion here. So let me run this bit here, and I just print in 3 instances where the spend is way higher than the upper limit that I just defined. And again, just trying to explain the logic here. I'm basically calculating the interquartile range, which is kind of like an idea here is that I want to see what is the usual range for the value spent. So what is considered like a normal variation for this value. And then I'm saying, let's get the Q3. So pretty much kind of on the end tail of this spend column. And then I'm going to add 3 times the usual range for this column. And then I'm saying, yeah, I don't want to see anything that is higher than this kind of 3 times the interquartile range. And then these are the instances where we have these outliers. As always, I'm going to then print our message fix applied. So let me put this one here. And then what I'm going to do is for those outlier mask in the column spend, I will cap it to the upper limit. So instead of removing these values, I'm going to say, okay, that is too much as an outlier. So I'm just going to put the upper limit. Again, that is a decision that I'm making. It's not necessarily the right decision. It's just kind of a logic that I'm using to clean these sort of outliers. And then I'm going to print the instances that we had before. So same line that we had before. Let me put this one here. And then as you can see here, this was the original values. And then now, instead of these massive values, I'm putting our upper limit. Then in our case is this 8603. Now, the other cool thing that we can do as part of our data cleaning process is actually a feature extraction, which means that I'm gonna create a new column based on an existing one. So let me explain exactly what I want to do here. So here I want to print the campaign name. I'm just gonna print the first 3 just to show you that in the campaign name, we have something like this, like Q4 and then summer and then ID. And what I want to extract is actually the season here. So summer or launch or winter, because maybe that's an extra information that I want to get from the campaign name. So what I'm going to do here is I'm going to define a new column called season. And this one is going to be equal to, I'm going to follow again the suggestion Google Colab. I'm going to get the campaign name. And this thing here is definitely very hard to read. It's basically saying that I want to extract only what is present after the first underscore and the second underscore, which is exactly this text here, the summer. I'm going to print our fix applied, as always, our message in our terminal. And then again, I'm going to get the 3 instances here. But then now, apart from the campaign name, I also want to select season, which is our new column. I think we are missing brackets here and here as well. Let me try to run this one. And there you go. We have the campaign name and also this new column called season, where we are just extracting something from the campaign name, which we might use later on for our analysis. And there you have it. I implemented 9 different steps for our data cleaning process, use different techniques, different assumption and logics, but hopefully you've seen end-to-end how I reason about data cleaning, how to actually clean your data and make it ready for analysis using Python and different techniques like, extracting string from text, handling outliers. Then we've seen also how to work with the dates. We check for integrity of our data. We check for duplicate columns. We change the data type for dates. We also handle mixed Booleans and categorical typos. We also fix the numerical values as well. And also we clean the headers of our data frame. So a lot of stuff that we implemented today. So hopefully this was useful. And there you have it, a full end-to-end data cleaning project using Python. If you found at least one useful information in this video, make sure to like and subscribe to my channel so that I can help you even further in the next videos. And if you like what we've done in this video and you want me to help you land a job offer in data analytics, then definitely make sure to check out my Analytics and Automation Academy. You have the link in video description, and I definitely encourage you to apply if you're serious about this type of career. We still have some spots open, so definitely make sure to check it out. I will also leave here in the screen another video that I made on data cleaning, but this time done with SQL, and we'll enjoy the rest of your day. Ciao for now, and see you in the next one.